Hi there, everyone. This is Ms. Page. In this lesson, we are going to expand upon the previous lesson in which we talked about how to graph a rational function using our knowledge of transformations to rational functions where their initial form doesn't work with that method, such as this one right here. Here we can't clearly identify the k value, but if we change its form using our skill of division, because remember, a ratio just really means division. So in mathematical terms, this literally means 2x minus 5 divided by x minus 4. Then we can, in this case, change its structure into a situation where we can identify the parameters, where like here, our a value is that 3. Our h value would be the opposite there of positive 4, and this plus 2 would be our k value. And then we can use the method that we were talking about yesterday. This does not work for all rational functions. Some are too complex, and when you divide them out, you don't get this form where you can identify the parameters. And for those, we will later on learn other methods for graphing. All right, so our first step is going to be to rewrite it in one of our two forms where we can clearly identify our parameters, either a parameter of a, h and k, or a parameter of 1 over b and our h and k. And then we'll use the same method for graphing that we used in the previous lesson. So notice your instructions, and this is one of the things that I often see people fail to do completely. We have to rewrite the function in one of these two forms, and which form it is will be dependent upon what happens in our division, or you can look at it as what your original denominator is. If your original denominator is a 1x denominator like this one, then you'll get this form. If you have a denominator that you have something other than 1x in that position, then you will get this other form. So we should have an idea of what form we're going to end up with given our denominator in the original function here, this one called g of x. So the first thing we have to do is rewrite this function. So we begin by dividing literally 3x minus 4 by x minus 1. And given our long division experience, this is a fairly simple one. So what times x equals 3x is 3, and then we distribute that, giving us 3x minus 3. And then remember, we have to subtract each of those. So before you combine any like terms, do make sure you change both signs. That would be a negative, and that's a positive. This gives us 0, and negative 4 plus positive 3 is negative 1. Here's how then we take this result and put it back into a function form where the function will actually match this form right here. So what we're looking at here is, remember that when we do long division, the negative 1 is our remainder, and we write the remainder over the divisor, which is our x minus 1. So this right here, that's our a value in this case, over our divisor, and then what we have up here in the quotient position, that turns out to be our k. So we end up with g of x equals, and then we have this negative 1 over x minus 1, and then we have plus our k value of 3. Make sure, this is what I was saying people fail to do completely, make sure you have a function form here, that you don't just do the division, that you actually rewrite the function in the form, the new form. So after this, then we will be ready to graph the function based on our strategy from the previous lesson. So I'm going to start by drawing those axes. And I'm looking here, like I said, negative 1 is our a value. And the one thing I guess we haven't yet identified is the h, which would be the opposite of the minus 1. So we've got h equals 1. So we're going to go to the right. Our 3 for k makes us go up those 3. And then our a being equal to negative 1 gives us an x-axis reflection. But since the absolute value of negative 1 is 1, there's no stretch and there's no compression. Just the reflection in that case. All right, so given that we are going up 3, I might want to drop the x-axis down a little bit. And then right one's not that big of a deal, so y-axis in the middle should be fine. Then we're going to draw those asymptotes, which remember have to be dashed. So I'm going to transform my asymptotes from my axes. So up 3 makes my horizontal asymptote move up here. And we are going right 1, so that makes our vertical asymptote move over here. Then we're going to use those two nice points, that are the 1, 1 and the -1, -1 that are on each piece of the parent function for the rational family. So 1, 1, we want to make sure we do this reflection first across our x-axis. So it moves here, and then it's going to move right 1 and up 3, 1, 2, 3, and end up right there. -1, -1 is going to reflect across the x-axis to here, and then move right 1 and up 3, 1, 2, 3, right there. That does not make any sense. Something I counted wrong. Oh. Don't do what I did. Actually, I think that one was fine. So, this is one of the things, it's not a bad mistake for me to make here, that will demonstrate something you want to be careful of. Our eyes often confuse or mix up asymptotes with our axes, and so we think we're graphing a point in a particular place, but we're really not. And that's exactly what I did, because I used this as my 1, 1, but remember that this is my origin, so that's actually 2, 1. 1, 1 is actually right here. And so I have to reflect that, which moves down here, and then go right 1 and up 3, which puts that final point right there, not where I originally had it. So, not a bad mistake to see being made. So you want to be super careful there. And then also, so there is another way that you can actually, and I'll share that here, to potentially avoid that type of mistake. You can start with your points translated into the positions of here. This is where 1, 1 would translate. Notice it's 1 unit away, 1 unit to the right, and 1 unit up, away from where the asymptotes intersect. And then start with it here. And then just do your A stuff, in this case reflection. So this point would reflect across now, not the x-axis, but across the horizontal asymptote up there, and this one would reflect then down there where we have them. That is actually another strategy, and I'll talk more about that. If that didn't quite make sense, I'll talk more about it in the next one too, if it works well. All right, so now I want to draw in my curve pieces. So going through this point, and again, I want to make sure that my curve goes towards my asymptotes, not the axes in this case. And that would finish this one. We're not going to do any characteristics of this one. All right. Next, we have a practice problem for you to try. So pause your video here and give this problem a try, and then come back when you're ready to check with the answer. All right, let's take a look at the answer. So here is the function rewrite that you should have. We have an a value of 2, an h that is -2, so that heads to the left. That's what we're looking at here. Now notice the scale on this particular graph is a half unit scale, so this is at -2 right here. That's 2 units to the left. And then we have a k value of 3, and so we moved up 3 from the x-axis, which is here. So notice this is 2 and this is 4, so this is 3 units above the x-axis. All right, now let's talk about one of the things that we can do here. Like I said, if you wanted to start with your translations, then your 2 points, 1, 1 would translate to 1 unit right and up from this point of intersection right here. So 1, 1 translates to right there, and then all you have to do in this case is the A transformations, which would be a stretch by a factor of 2. And notice that it goes from 1 unit above the horizontal asymptote and stretches to 2 units above the horizontal asymptote. And then -1, -1 would start right here, and this 1 unit distance would stretch to 2 units of distance to that point right there. And so that's the other strategy of graphing those 2 points that you can try if you would like to. All right, let's take a look at this final example here. Okay, so again, we want to start by rewriting our function. So this literally means to take the 4x minus 7 and divide it by -2x plus 4. Remember that when you do division, that whatever this first term is here times what you put in your quotient position has to exactly equal this first term of 4x. And so that would be a -2 in this case. And then we get 4x minus 8. Then remember, we are going to subtract each of those. So before we combine any like terms, we want to change the signs. This becomes addition, 4 becomes negative, -8 becomes positive. And then this is 0, -7 plus 8 is +1. So again, what we're looking at here is this would be our a value. This would be our k value. So when we rewrite it, we've got g of x equals 1 over -2x plus 4, followed by plus -2 or -2 is how we normally write it in that function form. Now, I guess, quite honestly, this is not quite my final answer, because take a look at the form I'm supposed to use. This is my graphing form. Remember we talked about in that previous lesson about this denominator, is that 1 over b has to be factored out. And that's what this -2 is. This -2 is our 1 over b. So we should expect to get this form right here. And so I would actually want to factor -2 out of that, which would give me x, -2 times x be -2x, and then -2 times -2 would give me that plus 4. So I'm going to now change this denominator to its factored form of -2 times x minus 2. That matches the directions structure. All right, so now, again, I'm now going to graph this using the method of transformations. So I'm looking at k of -2 going down 2. So maybe I want to move my x-axis up a little bit, but probably not necessary. And I've got an h value of +2, which is going to take me to the right 2. So might move that a little bit to the left, but maybe, again, not necessary. Then I'm going to look at drawing my asymptotes. So again, they're going to translate from the axes according to my horizontal and vertical translations. So again, k is -2, so we're going down 2, so that means the horizontal is going to be here, and h is +2, which is to the right 2, so my vertical is going to be here. All right, so now I'm going to again use that other method. Instead of starting at 1, 1 and -1, 1, I'm going to start with them in their positions relative to the intersection point of the asymptotes, which would be here and here. And then all I'm going to do, remember a is 1, so I don't have anything to do with an a parameter, but I have this -2 here, which is my 1 over b parameter. So if 1 over b is equal to -2, then b would be its reciprocal of -1/2. Since it's negative, I have a y-axis reflection. And the absolute value of this is +1/2, which is less than 1. So I also have a horizontal compression with a factor of 1/2. So what happens then is I have to do these 2 transformations to my points here and here. So I have to compress horizontally by a factor of 1/2, which would move the point to here. And then I want to flip it over my y-axis, which would make its final position right there. This point here would compress to half its distance from the vertical asymptote, and then it would reflect to the other side, which would put it right there in the final position. So getting rid of this work, I now have my 2 pieces, and I can draw the curve in approaching those asymptotes. Like so. All right, that finishes up this problem. There is a practice problem that follows for you to give a try of this particular type. So why don't you pause your video here, give this one a try, please, and then come back when you're ready. All right, let's take a look at the answer. All right, so here is the structure of our rewritten function. This I've literally written -1. More often you would just see the negative sign in front of the parentheses. So if you wrote that, that's an even better form, quite honestly, a little simpler because we don't really need the one with the negative there. So what we're looking at is that -1 is our 1 over b value. That means we do have a y-axis reflection, but no horizontal stretch or compression because the absolute value of 1 is 1. And then we have an h value that would be +3, so that's going to take you to the right 3, and a k that's -1, which takes you down 1 unit. So you get this scale right here is a half unit scale, so notice here's -2, so this is -1, and this is 3 to the right for those positions of the asymptotes. And then what's happened is that this point has reflected across the vertical asymptote to there, and -1, -1, which is translated to here, and then reflected across the vertical asymptote into its final position right there. All right, that ends this lesson. I hope you have a wonderful day.